Greetings, fellow chem nerds. Look like you need some help with writing chemical formulas. Let this be the last video you watch over this topic and never make a mistake again. So let us get started. So let's say you have two chemical compounds, silver chloride and carbon tetrachloride. The first question you need to ask yourself is this compound ionic or covalent? Remember that an ionic compound must start with a metal. A covalent compound must start with a nonmetal. So if you look at the first one, silver is a metal whose symbol is Ag, and because silver is always one positive, we put a one positive symbol on there. Now as far as the nonmetal goes, you have "ide." Now this "ide" suffix tells you that chloride is simply the element chlorine with the one negative charge. Anytime you see a name ending with "ide," it means that it's an element. Okay, so you just need to look it up in the periodic table. So now that you have Ag is positive and Cl is one negative, they perfectly cancel each other out, and the formula you end up with is AgCl. On the other hand, you have carbon tetrachloride. So carbon tetrachloride. Carbon is C, and chloride, just like in the previous one, is simply chlorine. However, in this case, you will not put any positive or negative symbols over here, because in covalent compounds, okay, covalent equals no charge. And we must always remember this. Covalent compounds do not have a charge. So now you look at the prefixes. Tetra goes with chloride. Tetra means 4, so you put a 4 on the bottom of Cl. Carbon has no prefix, so there's no subscript for carbon, and so you end up with CCl4. Diving a little deep into writing formulas for ionic compounds, what I have noticed is that students struggle mostly with writing formulas of ionic compounds because you have things like sulfide, sulfite, and sulfate. Now they all sound super similar to each other. They all have sulfur in them, and it's understandable if someone might get confused as to what their formulas are. So if you look at this chart, you will notice that if you focus on the anion part only, you have two types of anions. You have a monoatomic anion and a polyatomic anion. The polyatomics are always on the back of the periodic table. Monoatomic ions are on the periodic table. Okay, monoatomic ions are mono, meaning it's just one element. So sulfide, in this case, is a monoatomic ion. You know that because you notice it ends with IDE. Ide makes it monoatomic. Okay, so it is very important that when you look at the spelling, you're able to figure out if it's monoatomic or polyatomic. Now that you've figured out that this is monoatomic, sulfide comes from sulfur, and because sulfur belongs to group 6A, okay, belongs to 6A, everything in 6A is 2 negative, so sulfur would also be 2 negative. Now anything that does not end with "ide" automatically becomes polyatomic, okay? Polyatomic ions are on the back of the periodic table. So what does "ite" and "ate" mean? We've talked about how 8 are called base ions, okay? And so we compare all other ions to these base ions. And so when I say sulfite, this "ite" means one less oxygen, okay? And then there's also hypo meaning 2 less, okay? So the suffix "ite" and "ate" are going to fall under the umbrella of polyatomic ions. So here are two very similarly sounding chemicals. The first one is calcium phosphite. The other one is calcium phosphate. Now, as soon as you look at the names of these elements, you will notice that this compound ends with "ite. This compound ends with "ate." That tells us that both of these elements are polyatomic compounds. Polyatomic means many atoms. Now that we know that this is polyatomic, all you have to do is refer to the list of polyatomic ions. Most likely, you will find phosphate in it. Phosphate is PO4 and 3 negative. Now, if phosphate, which happens to be a base ion because it ends with 8, has 4 oxygen atoms, then we know ite, anything that ends with ite, is 1 less oxygen. So, by extension, phosphite would be PO3, 3 negative. Remember that the charge on top is not affected if you change the number of oxygens. So I went from 4 to 3, but the 3 negative on top stays the same. Now that we have figured out the formula for the anion part, which is the second word in the name, okay, phosphite and phosphate, we turn our attention to the first word in the name, which happens to be calcium for both of them. Calcium, as we all know, is Ca. And when you write the symbol, you need to find what part of the periodic table does this metal belong to. Calcium, as we know, belongs to group 2A, called the alkaline earth metals. It is important because alkaline earth metals have the common charge of 2 positive. Everything in group 2A will always be 2 positive. That goes for everything from beryllium all the way to radium. Everything in group 2A is 2 positive. Now, 2 positive and 3 negative obviously do not cancel each other out, in which case you flip the charges. So this 2 over here is going to end up here. This 3 over here is going to end up on the bottom of calcium. So you write Ca with a 3 on the bottom. You will ignore the positive and the negative signs, and then you will put parentheses around PO3, and then a 2 on the bottom. Those parentheses are important because the parentheses are going to enable you to separate the 3, which belongs to phosphite, from the 2 that you're putting on the bottom of the ion. Otherwise, it would look as PO32, which is obviously not the case. So if you ever end up in a situation where you have to put a number on the bottom of a polyatomic ion, the polyatomic ion must always go in parentheses. Similarly, you can flip the charges on calcium phosphate, and so Ca will get a 3 on the bottom, and the PO4 will go in parentheses, and then you'll put the 2 on the bottom of PO4 as well. And so this is how you figure out the formulas for polyatomic ions. There's one last thing left, and that is a discussion about the case of transition metals. In contrast to group 1A, which is this right here, and group 2A, which is this right here, the transition series, which is all of these, does not have a fixed positive charge. Like, we know that 1A is always 1 positive and 2A is always 2 positive. The transition series has a positive charge, but how many positives does it have is not fixed. Like, for example, chromium might be 2 positive or 4 positive, or sometimes even 6 positive. Iron could be 2 positive or 3 positive. Copper could be 1 positive or 2 positive. So how many positives you have, it really depends from element to element. There is no set trend that we see in the transition series. And so to fix that, the name of the compound will always contain a Roman numeral in the middle. This Roman numeral tells you that copper, in this case, is 2 positive, because this is the Roman numeral 2, So copper, which is Cu, in this case would be 2 positive. And as you know by now, sulfate is SO4, and SO4 happens to be 2 negative. This 2 positive and the 2 negative will cancel each other out, and you will be left with the formula CuSO4. And so writing formulas is a very easy process, but it is something that you definitely need to practice every day and over again.